We don't do real-time calculation because like we record the data for each particles. It's quite take a lot of memory of the system. It's really hard, so we do it after. So this one. So the data is here, demo. We import the file and then process it. So it's, at this step, take the laptop CPU and the GPU to calculate the data. It takes a while. It depends on the length of the measurement and also depends on how many particles it's handling. That's why we usually suggest 250 or 500 enough. If you see our customers' application is just usually like 4 in 250 and then or like 500. But if it's some like, for example, pharmaceutical company want to see some samples or detailed data, first we need to check. Oh, sorry, cannot. With the increasing of the pressure, so the flow rate shall be higher. So it's another step of QC. After checking that one, we check in the sample. It's also following the same trend. Oh, that's good. So then we click the calibration. It's multi-pressure calibration. You can either choose 2 pressure or 3 pressure. After calibration, that is the actual number of the samples. And then also can choose to view the histogram. Yeah. You see there's some particles that is not clean efficiently. So because I just use that one, you can still visualize that. And if you want to see the detailed data, so let me see. We can actually see each dot is a particle we measured. You see that is a not clean sample, or say, the previous one was not clean. So it's good and bad. Sometimes you're doing experiment, some particles not clean. Just basically the how TIPS measure the samples. You can see that it's not taking not much time, so it's a record like the time to measure. So it's for one pressure, it takes around 1 minute, so it's like 3 minutes to do it. And for the calibrations, it's also around 1.5 minutes, so it's like 4 minutes. Add up to around 10 minutes, considering your pipetting time. So let's say like within 20 minutes for samples for experienced users. So is there any of your? You can choose who want to practice. I can the duration. This one converted to the relative surface charge and the blockade duration. So you can see it's in relationship with the surface charge. This is the size and the concentration measurements. We can also show later how to do the zeta potential measurements, and also we can produce different like a report. For example, this is a standard report. So that's the one we need. Because the sample particles is sample S is actually a calibration particle for 350 nanometers. So we see. Let's see which is sample S. Yeah. This is the solution S. Okay. This is the mean value. Yeah. We use the we use the TKP 200 as calibration, and the usage is measurement 3 to 8. Yeah. Mean value 3 to 8. Okay. Exactly the same, and the concentration 9.78 E10. Our concentration is 8.6. Why? It's different because pipetting error and also dilution error. But usually we think like concentration is hard to make it very accurate. Usually within 25% is acceptable. Because why we said concentration is very important. If we do in the in vivo study, you need to dosage based on the particle number. For example, a patient needs 10 to the 13th like particles per injections. That means you need a very accurate like a concentration level. And if you use the optical method, so the concentration error is more than 60%, how do you make sure the dosage is due to the different level of dosage or the measurement error, right? So that's why we suggest to a lot of like NTA customer return to us.
Yeah.
And I said that can you do the measurement and then show with us and how's the concentration. As a paper I show in the morning, there's a JUV paper. So that customer got the NTA, so it's the nanosite, and they come to us later and said they want our measurement. So they published both of them.
Yeah.
Data at the JUV. So yeah, this paper. So you see this published last year. So this is the group in Australia.
Yeah.
And it's actually in vivo study. So you see, it's confirmed. We are not saying by ourselves we are accurate. By the TM date, you see the particles is around 100 nanometer. But you see the NTA, NS300, they give the mean value of 300.
Yeah.
It's quite a bit off. The reason is that because like UV samples is not like a mono distribution.
Yeah.
It's like multiple peaks distribution, and it's an optical method just give the wrong estimation of it. And but they use our EXOID and then get the 97 mean size. That's good.
Yeah.
Because basically I talked in the morning, because like usually for preparing for those like in vivo samples, injection samples, you need to do stereo filtration. Usually, for example, we know that the 0.22 filters can be used to do stereo filtration, right?
Yeah.
But if you get like this 300 nanometers, you can, if you trust this date, you cannot use the 0.22 filter.
Yeah.
You will lose like most of the samples. But when we report this to customer, they relieved because they only need to keep the last step like a stereo filtration. It saves a lot of energy and money.
Yeah.
By using this one, you need to keep all the procedure stereo. Means like you need to do it in clean room, not only in like a cell culture room. You need to clean room with the clean cell culture hood.
Yeah.
And then you need your TFF stereo. You need your column stereo. But the thing is like, currently no one make a column stereo.
Yeah.
Not many people. Because if you make a column stereo, it costs the manufacturer lots of money. Usually, even the vaccination manufacturer, they use large columns. They just sanitize it with sodium hydroxide. It's not a stereo. Stereo means you need to use gamma radiation or ETO to sterilize it. It's not possible. It's not that possible, but it is spend a lot of money. It's not efficient. But when they make sure the size, it's the range they want, can easily use a 0.22 filter to do a last step filtration. And if FDA asks, we have done sterilized filtration and then tested into toxin by abundant, all meet the requirement. And even though our upstream didn't quantify stereo, we use clean techniques to maintain all the procedure, clean as enough, and we do the stereo at the final stage. By this way, save a lot of money. They don't need to keep everything stereo.
Okay.